Hi guys and girls, welcome to a Learn Electronics Repair Christmas special. Yeah, it's that time of year and I love it. Oh, it's just a wonderful time of year. It's just my thing, yeah. I'm a devout atheist. You know this, I've told you before. I'm a devout atheist, yeah. And I celebrate Christmas. It's fantastic, okay. So, I'm doing at least a couple of video specials here today, yeah, to entertain you also. If you had your Christmas lunch and a few beers and you want to chill out and have some fun, that's what I'm here to do, entertain you, yeah. So this is a graphics card. I made a video a little while back, and I'm now going to show you the hardest way to repair the easiest possible fault on the GPU using Boardviewer. Hey, yeah, okay, so say no more about it. Get yourself a mince pie, get yourself a beer or brandy or a wine, sit back and enjoy. Hi guys, it's Sunday. Yeah, I'm at the workshop. I'll just pop down for a couple of hours if I get a video done. Because last week I was really busy and struggling to find time to make videos. It was on-site work, basically installation work, but that's good. Went down to the car boot sale, the flea market this morning, but there was nothing I really fancied. There were 3 or 4 Acer computers down there, i3s, but nothing very exciting, so I didn't bother. Found a couple of motherboards, but again, they weren't very exciting. Yeah, and the weather's, I mean, it's sunny. It's sunny. It's probably about 24 or 25 now in the sun, probably a bit more in the sun, but it's windy. There's quite a cool wind, you know. It's very sunny if you're sitting somewhere sheltered from the wind, otherwise it's windy, it's cold breeze. So it's not sunbathing weather really, so I couldn't be bothered to go to the beach. And I've done the Christmas lights on the house, so yeah, let's go to the workshop. Next week's a funny week here. I just mentioned if there's not so many videos on the next week or so, new ones. So 6th of December tomorrow here is what in England you would call it a bank holiday, yeah. Elsewhere you probably call them public holidays, I guess. So Monday the 6th of December is a public holiday. Then obviously the 7th you're back to work. And Wednesday the 8th of December is another public holiday. So you get like 2 of them, but like with 1 day in between. So Monday's a bank holiday, Wednesday's a bank holiday. And then, of course, we have Christmas Day as a public holiday here. We have New Year's Day as a public holiday here. And then the 6th of January is a public holiday as well, yeah. And all the Christmas lights go off after the 6th. That's, I think, if you're religious, which I'm not, but if you're religious, I think it's called Epiphany. But here they call it like Dias Tres Reinos. Like the King's Day, the 3 Kings, Dias de los Tres Reinos, something like that. Can't quite get it right. So the Spanish watching tell me how much of that was wrong, yeah. And that's like Christmas here, basically. So yeah, we get extra bank holidays. I'll talk about that a bit closer to the time, actually. It's quite interesting, yeah. So here I am. This is one more of these that were actually here, number 4. This is, I thought it was actually the 750 Ti 2GB, but I'm wrong. It's actually the 760. It's a 760 Ti. No, I'm right. It's a 750 Ti, overclocked OC, or whatever it means, yeah. 2GB. So, yeah, this is off this batch. Very quick reminder, so all spares or repairs, some display picture on BIOS, no further tests. So far we've looked at 3 and they're all waiting for parts, but they're all quite likely to be repairable. And none of them will give a picture on the BIOS so far. So are we going to get any more luck with this one? Well, let's see. Okay, so first thing first, it looks clean. Yeah, it looks clean, this one. Obviously the thing's broken this warranty seal, so there's been off the heatsink. It looks clean. So yeah, let's get the heatsink off this one and let's get the microscope. Let's have a look and see what we've got here. Yeah. Okay. One moment and it'll magically come off. Oh, just before we look at this, yeah, Discord. So Learn Electronics Repair is now on Discord, yeah. in the link to this video and all future videos, you'll find an invite. Click on the invite and come and join us. Yeah, if you've not used Discord before, it's kind of like a cross between a chat room with multiple channels and a forum. And come on there, you know, we can all have a meet up there. We can post photos, you do live video on there if you like, and we can repair stuff together. Yeah, so it's been running a week now, and already it's a very friendly place. So yeah, you guys, if you're not on, come over to Discord. Yeah, and now let's repair this together. Okay, so it's quite clean, as I said. Just get the this off. No, I thought somebody maybe had been round here. Let's zoom in and let's have a look. I've just zoomed the overhead camera down first, actually. So yeah, it's like there's something that's been on here. I don't really know what to make of it. Yeah, here as well, and kind of here as well. Kind of like, I don't know if it's something on the board or if it's like where the solder resistors come off. Let's try a bit of isopropyl on it. So let's see if it's something that cleans off, or if it's something that's like missing, like the yeah, solder resist. Yeah, the stuff they coat the board with after it's made, shall we say? Yeah. Okay, let's give a bit of that on there. Let's see if this stuff actually comes off. I really don't know what it is, I have to say. I'm a bit puzzled what this stuff is. Let's have a look, clean that off. Let it dry out. Give it a bit of help. Yeah, whatever it is, it comes off. So, well, that's the first thing, and this stuff's going to have to come off it. Interesting to know what you guys might think this actually is. It's on the PCB side. Honestly, don't really know what this is. Yeah. It's like some sort of, almost like some sort of liquid's got in, but it's not corroded anything. It's kind of like at both ends of it. It doesn't doesn't make a lot of direct sense, you know, as to what that is. And it doesn't appear to be on the other side of the board. Yeah, even more interestingly, got you're high on that stuff. Oh, okay. So okay, so yeah, whatever that is, it's cleaned off the board. So we'll get the microscope and let's have a look around it. Yeah, let's see if we can spot anything obvious. I mean, when I say anything obvious, by the way, I mean anything more obvious than that, yeah? Okay, so yeah, let's just get a bit of a look. I mean, normally you'd expect this side of the board not to have any, like, you know, broken off components and such like. It's not easily to get physically damaged. I mean, obviously, something could have easily been messy on it, yeah, it'll work. That looks like it was always missing. So a bit of a look around. So, as per usual, guys, shout out if you spot anything. After all, that's what the comments is for, anyway. Yeah, I'm sure I'll hear about it if I missed something on here. That looks, yeah. Not really any components in this area. Yeah, let's have a look around. This is into the RAM now. Actually, I mean, one thing I will say about this board, it's not particularly densely populated with components. Yeah, there's not a huge amount of stuff on this actually. Most of it's fairly clear. Regulator, book control or something there. So this only has power from the PCIe. Yeah, there's no 6-way or 8-way. Okay, let's go on the other side. Let's have a look, see what we've got on this side of it. See if anything's been knocked off the board as we can spot. Again, it looks fairly good to me. Yeah. Just check all these little capacitors along here. Oh, they look alright, okay. So I've looked down here. That's behind the GPU. Okay. BIOS chip as a guess. I haven't looked at the part number, just a guess. Looks like one. Yeah, just focus it. So I don't see anything obvious, particularly with this. Got a couple of LEDs on it. Must light up for some reason. Yeah. Okay. Yeah, so that looks pretty much all right. Okay, so let's get the meter out. Let's check some resistances. Okay, so the first one then, the power rail's coming in. 12 volts is on the first three fingers here. 1, 2, 3. And 3.3 volts is on the fourth one in from this end, which is here. So let's check the 3.3 first. Yeah, 1.9k or something. That seems quite reasonable. Okay, 12 volts. Quite a high resistance, so there's no shorts. Okay. You've got 3 coils here, which looks like they're on 2 different voltage rails. So I'm thinking these 2 are probably V-core, and this one might be something like memory controller, and this might be RAM. Just thinking, yeah. So let's have a look. From the coil to ground, yeah? So from this one, 8 ohms, that must be the V-core, and there's this one the same, another phase, 8 ohms, that's 2 on that one. What's on the third one? Okay, so all 3 are actually together, yeah, 8 ohms. So those 3 are going to be the core voltage for the GPU. There's one over this top end over here. I'm guessing this is probably then VRAM, which is a fairly big one. And that's reading quite high, 320. If that's VRAM, that to me is unusually high, yeah. Well, I'm not familiar with these cards again. And that's really it for buck regulators, just the 2. This thing over here, I'm pretty certain will be a 5 volt regulator. That'll be probably this end's coming in from the 12. Just need to just push my meter leads in properly. Pretty sure this is the input. Yeah, from the 12, yeah. And then from the output, which is almost certainly this end to ground, there's no short. So this might be ground in the middle tab. Yeah. So I'm pretty sure that's a 5 volt regulator. There's a little chip down here that could be a regulator. I'm pretty sure this is the BIOS. That's about it. I think we have to power this one up then. Don't see any problems with shorts. Let's power it up and check the voltage rails and see what we've actually got. Just before we do power it up, I was just looking at the configuration of these MOSFETs here. There's 6 of them. There's 3 coils. And there's quite often you have like 2 low side and 1 high side for each coil. Well, having these 3, 1, 2, 3 are all of a particular type, yeah, say 3056 on them. And these 3 say 3054 on them. So I don't think there's something missing from here. If anything, it would probably like another set of low side MOSFETs. So like say maybe the 3054s are the 3 high side, and then maybe 6 low side as possible. I haven't tracked it out, but nothing seems to be missing from here. These don't look to me like they've been desoldered, they really don't. So I'm going to give it a go, let's see what it does. Okay, we're ready to go. So let's get the test meter. We'll start it up, see if it starts. Lights on, got a light on, good sign, possibly. Check some voltages, I bet V-cores down here. Let's go for the coils, it's easy. So, nothing on V-core, basically. neither is damn it nothing. Yeah, what's on VRAM? That be, if it is VRAM, this big coil here also has nothing on. Yeah, so nothing on either of those. So I think we can say, surely enough, this isn't getting warm. Yeah, because there's no power to it. Let's see what power supplies we do have on here. So I'm thinking this is the 5 volt regulator. I'll zoom it down a little bit so you can see it. Oh, and if John, did you notice I put all insulation, like tape stuff on here, masking tape, yeah? So I can't accidentally short any GPUs, as we were talking about, to the metalwork. Okay, let's just get the focus right on this one, and then let's have a go. That's about on, close enough. Okay, so this I'm assuming is the 12 volts coming in here. That's 12 volts. This should be a 5 volt regulator. We've got 5 volts coming out of that one. With a little chip down here, I'm not sure what it was, but it looks a bit like a regulator. So let's have a look at these capacitors around this, if we can find any voltages out of interest. I mean, so far we've got 12 volts and 5 volts. So have a look at these capacitors around here, see if we can see anything. It's 5 volts down here. What's on these ones? I just see 5 volts down here. I'm not sure what this chip is, but I've got a suspicion it's probably like a linear voltage regulator, and maybe it should have something coming out of it. So I think that's probably the first place we can start to see if we can find out what that is. As we said, this one up here didn't have any output on it, just a little bit of voltage. And the same on the V core, which I'm guessing we can probably find some capacitors somewhere around here. Maybe, just on the input side. That's the 12 volts input side. I can't get to the coil, so there's 12 volts coming in here. This is to the these, I would think, the FETs, and there's nothing seems to be coming out of here, but I can't easily seem to find a capacitor on this side to measure it anyway. Okay, let's have a look to see what this thing is, because I can see 5 volts getting to this, but no other voltage. And if it's a voltage regulator, then that's probably a very good place to start. Okay, this is a device I just spotted. It's EM5106. I don't know what that is, or if that's the port number this thing isn't, but we can have a look. Yeah, I don't know what this is, but I do have 5 volts coming in this area and nothing on these other capacitors, which makes me think possibly this is a linear regulator, 5 volts in and something else out, maybe 1.8, and it may be not working. It's just supposition, but I'm kind of on the assumption that there's 5 volts here and there should be something here. That's if that's what it is. We'll have to have a look. The other thing I just had a quick look is the 3.3 volts coming in, which we didn't check, but basically the 3.3 comes in on this 4th finger in here. Yeah, so 1, 2, 3, 4. This is your 3.3 coming in here. Yeah. I have to use the microscope. You can see how I can't use this on the screen. I'm looking at the screen at the moment, yeah. And this goes to here. So that there is a 3.3, we know that. Let's have a look at this component now. Let's see if we can find a data sheet for it and see what it actually is. Okay guys, it was a guess and it was a good one. It is a low dropout linear regulator. Let's have a look at the data sheet and we can figure some of this out, I'm sure. It'll probably give us at least a place to start with this, yeah? Okay, so let's go and have a look. Okay, so this is our chip. So basically it's got voltage coming in, which I'm sure is going to be the 5 volts. Enable, which must be high. If it was active low, by the way, it would have a line across the top normally, or a star in front of it, both of those. If you see this sort of thing on schematics, or EN like this, or like this, yeah. Not very good asterisks, was it? There you go. If you see that or that means it's active low, yeah. So this is active high. This pin pin 10 CNTL is actually what called control voltage, and this is the voltage supply to this chip itself. Yeah, VN is what effectively generates the V out. So we should have a power on here, power coming in here, which may or may not be the same voltage. This is an output power OK, which goes high if it's working, and this is your V out. And at feedback, there's a couple of resistors that set the voltage on here, which effectively sets the output voltage. So let's have a look to see what we've got on ours now. Here's our regulator then. So it's kind of mounted upside down compared to our diagram. So pin 1, this is the power OK, which is an output, yeah. Then feedback, and then these three here, 1, 2, 3, are all connected to V out. I'm going to use the microscope so I can get a good connection to this. So from here, I'm guessing these are probably the output capacitors. I'll just put my meter to make sure it's on, it is on continuity range. Yeah, it's bleeping, okay. Right, so, right, yeah, so, yeah. So this is the output, yeah. And then the other end of these capacitors, these will go to ground if I just find a ground somewhere on this. Yeah, so these are output capacitors, I guess, and this is the output rail here, yeah. And then the inputs are on these three here, 1, 2, 3, yeah, doesn't matter where I get in here. And this will go to one end of these. And this is where I saw the 5 volts, yeah. So we've got a connection to there, and then again the other side of the capacitor to ground, yeah. And both connected together, but it gets both connected together. Yeah, so we've got 2 input capacitors, 2 output capacitors. Okay, so we need to, well, we know we got 5 volts here. We know we've got nothing here. We can check it again, yeah. We now need to know what we've got on this CNTL. This is the pin 10. So CNTL's pin 10 is here. This is the power supply to this chip, yeah. Does this go to this capacitor? Yeah, good guess. Another other side goes to ground, I would think. Yeah, and there's no short on the capacitor, I'm hoping. Okay, so power in, power to the chip, power out, yeah. And the last thing we want to just check is enable, which is on pin 9. Okay, so the enable comes in here on this one, and may, as a guess, go to this resistor. Yeah, it does. 4.7 ohm resistor, yeah. I haven't got my glasses, I can't see which side, I'm sure you guys can see, yeah. So this resistor is the enable, power to the chip, power in, power out. Right, we got everything we need there to actually check it. So let's power our board up and let's see what we've got on ours. Okay, it's powered up. Let's see what we've got on ours. So you get a good ground. So the first thing we want to just check is power in. I'm going to try to do it without using the microscope. So this is where I saw the 5 volts. We'll just get a good ground. Get a ground on. Can I get a ground? Ground. No. I'm sure that's 5 volts here somewhere before it can't be on this side. This side of the ground. Oh, okay. That's interesting. Let me find the 5 volts. I know it's here somewhere. Okay, guys, I found it. I knew it was here somewhere. It just wasn't where I thought it was. Okay, so the 5 volts was actually on this capacitor. This is the supply to the chip, yeah. The one that was marked CNT. I'll just turn the meter around so you can see it, yeah. Okay, so 5 volts on here. Yeah. This is your enable, which is also high. So the chip's got power, the chip's got enable. It's actually got no input, and obviously therefore no output, yeah. So the next thing to trace is where this gets its input voltage from, and probably the best way to do that is just poke around with a meter or see if I can follow the track. Let me have a look to see where that actually goes to. Okay guys, so I had a quick poke around and decided there's probably a better way to do it. So it doesn't go to the 12 volt, but we know we've got 12 volt coming in, and it doesn't go to the 5 volt. We've got 5 volts here anyway, so why wouldn't it go for the 5 volts unless there's like a break in a track here? You know, there's no point having like more than one track coming over with 5 volts that I can think of. Yeah, so I thought I'll have a look on the data sheet and see what voltage the VN is. Is it going to be 12? Is it going to be 5? What's it going to be? Yeah. So this is the data sheet, and it mentions this is for V control, VCNTL. This is the VCC to the chip itself. Yeah, can be 3 to 6, but this is chart is for this equals 5. Yeah, so this equals 5, and if you look at the voltage in, somewhere it's down here, I'll find it. What was it up here? Power input voltage, voltage in. Yeah, it got to be at least 1.05, and the most it can be is V control. Yeah, so it's got on our board between 1.05 and 5. It's got to be somewhere in that range. And I've not found any other voltages. I mean, I found 3.3, yeah. So it could be coming from 3.3, and I've tracked it to the 3.3. It doesn't go there. I mean, possibly a broken track. So I then thought, let's have a look to see what we can find for this. A schematic, yeah. Now I have many schematics, and in fact on the Discord server now, all these schematics are uploaded for you to download for free. Yeah, so I've given you all of my schematics, which is several thousand of them, for motherboards, graphics cards, and a few others. Yeah, so that's another good reason to go to Discord, by the way. Yeah, free schematics. And if you've got schematics, you know, let us know. You can post them in there. Yeah. So I have this ASUS one, and this is a Boardview file. Now, this turns out to be basically the one that we have. If you've not used Boardview before, this is going to be a perfect option to learn how to use it. So this is effectively a view of our board. It's kind of like upside down. This is a PCIe connector here, yeah. So the first thing we can do with this, I'll just show you, is we can flick the board over vertically, yeah, and we can also flick it horizontally, and we can get it. That's the way around it is on the bench, yeah. And our chip is down here, okay. You can view the bottom or the top. I've got a feeling what I'm showing you is actually behind the little inset, yeah. So view, this is where you flick the board horizontally and vertically, yeah. And you can also in here, you can also view the top or the bottom, yeah, of the board. Okay. So this is our board, and the area we're interested in is this area. This is our chip, yeah. This is the capacitors where the input voltage should be, which we don't have. The output voltage, yeah, which we don't have, and this is where we have coming in the supply to the chip itself, which was 5 volts, yeah, on one of these. This one, yeah, that's your 5 volts coming in, yeah. So we have, I think that's the 5 volts coming. I'll just be sure. Obviously enabling the 5 volts to be connected together. Okay, fine. So what we're interested in anyway, to be honest, is the voltage coming in, which is here. Yeah. Now you can see when I click on here, the red ones are the point I'm clicking, yeah, and the yellow ones are all the other points that are connected to that. Okay, that's how it works. So if I click on the pin, that goes red, and all the yellow ones are connected directly to there. Yeah. If we zoom out on our board, you'll see that this doesn't go anywhere else on the board. Otherwise, it will come in yellow. Yeah. But obviously, the voltage is supposed to come from somewhere. Now, these are capacitors. If I click on one of these in this panel here, look, it's showing you. It's a capacitor, yeah. Pin 2 is ground. Ground goes everywhere, lots of yellows, yeah. And this voltage is called PEX VDD VIN, voltage in shape. That's what it's called, yeah. And that's the input voltage, okay. It goes to here, and this is a jumper. Look, it's marked PJP1, yeah. And the other side of the jumper is where it goes to. It actually goes to, in fact I hover the mouse over, FBVDDQ, yeah? It's showing you underneath that with pin 1, PPEX VDDV in shape, and pin 2, FBVDDQ. So if I even hover the mouse over it, actually tells you, yeah? So that's where the voltage comes in from. There's a jumper, and I'll show you on the board in a minute, yeah? And that jumper, I'm just scrolling the wheel, goes all over the place. This is where the voltage goes, yeah? And so what we need to do next is to find out where this voltage supply comes from, because this obviously must be there to power this up. So this is the previous voltage. And we know there was no supply to the RAM, so we now need to look and see where this one actually comes from, yeah? I'll just show you on the board as well, and then we'll have a look. Okay, so this is our chip, yeah? This is the enable signal, this is the power coming in we've got, this is the voltage we haven't got. And look, this soldered bit here, this is the actual jumper, yeah? So this is the voltage coming in, VDDQ, yeah? And this is what we need to find. So let's go back to the board view, let's have a look to see where that's generated. So this is the board view. We can have another quick look. So this is the regulator we were just looking at. And this is the jumper, part PJP1, it's a jumper. And you can see that this side of it is this PPEX VDDV in shape. That's the voltage into this regulator. And the other side, FB VDDQ. And we can see that comes from over here. You see it goes to lots of capacitors and similar things, and to the memory chips, it goes to the GPU. But it also comes here. This square thing, this is the coil, and we can see that on the board. So we can have a look here. Now I hope, because I've been trying to teach you this stuff, you'll recognise this circuit. So we have one coil, we have two MOSFETs here, which are probably the low side, and one MOSFET here, which will be the high side, most likely. Now we can actually have a look. So we click on the other end of the coil. This is the one that connects between the junction between the two low sides. You can see it's in yellow, and the one high side, okay? So the other side of this MOSFET here, this will be to the 12 volts coming in. In fact, it's telling us 12 volts. And the other side of this MOSFET will be ground, and it shows us here ground. You can see ground goes everywhere on this board, of course. So the other pin, the little one here, in fact, when I hover the mouse over, you can see it's saying PMUG30, UG being upper gate, and then it shows us the part number for the actual MOSFET. And these are the PMLG30, so this is the low gate. So the gates of these will go to the controller that supplies a pulse width modulation to this buck regulator. If we click on this one, you can see it goes to this chip. So this is our controller, this chip here. We can see it's got a part number, it tells us here, sorry, this is the MOSFET part number. If we click on where it goes here, this is the controller. In fact, you can see on the drop down it's an EM5305VT, that is the controller. So this pin is the upper gate drive. Now we can look up the data sheet for this MOSFET, sorry, for this controller. But we can probably work this out from the board view actually, which we have here. So it's 13 pins device. We can see 10 on the diagram, and the other ones will be like underneath, yeah, they're like ground pads which are underneath it. So we can see this one is marked boot, and that'll to do with the start of the chip, upper gate drive. Phase effectively monitors the MOSFETs to see when they've actually turned off. So effectively it sends a signal to the MOSFET to turn off, but the MOSFET might not turn off for some microseconds or nanoseconds, and that phase effectively tells the controller that this MOSFET is off, so it then can turn the other MOSFET on. Yeah, obviously both MOSFETs go on at the same time. You've got a short straight through there. Lower gate, VCC20. This will be the supply to this chip. You see it comes through here. This is supply, feedback, enable. So that's the pins on the chip. So the ones we're mostly going to be interested in here are going to be the VCC. Does this chip have power? And the enable, is the chip enabled? So now we've looked at that, we can go back to our board and we can find this. We can look at the data sheet as well, and we can see how this looks on our board, and we can start to take some measurements. So this is our inductor coil, yeah? You can see here, we can see that. So one side basically is the voltage, the VD, I can never remember what that thing's called, yeah? VDDQQ or whatever, yeah. Upper side and lower side MOSFETs. So you see straight away our board only has one fitted, yeah, which is not unusual. They reuse these boards for different things, yeah. These here 2 MOSFETs, and this is the controller chip we were just looking at on the board view. Is that the same type as the other? Let's just zoom down. Let's have a look to see what this chip actually is. So another one of these EM, yeah. EM5305, okay. So we can now look at the data sheet for that one. Okay, so I have the data sheet for this chip. Let's look at this one. So this is a typical application, yeah. And the things we're interested in again, power to the chip, VCC. Okay, this one is between +5 and +12, it says. I'm guessing well, it's going to be one or the other, yeah, obviously. I'm guessing it's going to be one or the other because there's nothing in between on the board, yeah. Power into the MOSFETs, this will be the 12 volts. These are your high side and low side MOSFETs. We have this pin, comp/SD hash, yeah. SD hash, the hash is a bit like putting a star. That's an active low signal, and I believe it means shut down. Now you'll see it says enable low, disable high. That's showing effectively in the circuit a gate for MOSFET. So if this is high, disable, this MOSFET is turned on and it shorts this pin to ground. If enable is low, yeah, this is off and this is high. So it's kind of like a bit back to front to what you think that is. But it explains it in here. So what we're interested in, VCC on pin 5, yeah, we want to see has the chip got power, okay. This one, SD, I think is shut down low, yeah. So it's saying that if you're pulling this pin lower than 0.4 V, disables the controller, yeah. So low hash, shut down low. That could also be SD with a line above or star SD. They all mean active low, yeah, just different ways. So we're interested on what's on pin 7, must be high, or at least more than 0.4. And what's on pin 5, this needs power, 5 or 12 volts. Okay, so let's have a look at our board now. Let's see what we've got on ours. Here's our board then. So again, I'm going to find some components nearby, yeah. Pin 1's got the dot. So pin 5, which is here, this is VCC. Oops. Get it onto the thing, you'll see it. Here we go, yeah. I'll use the microscope, it's easier for me. Okay, so pin 5, which is here, this is the input, the VCC, and I'm guessing it goes to one of these capacitors. Yeah, it goes to there, so we can use that point to measure VCC. Enable, which is on pin 7, will go somewhere here. Yeah, it goes to this, whatever this white component is here, yeah. Not sure what this component actually is, but it goes to there. Okay, so that's the enable pin, which needs to be high. The other things we need to check really while we're here is the high side MOSFET, whether it actually has 12 volts. So I'm going to go from, I'm guessing this is the high side, put the glasses on 1 moment. Now I'm going to measure to the PCIe coming in on the 12 volt pin, so that's the high side. And the low side, maybe here, should go to ground, yeah. So we've got supply to that, we need to see have we got supply to this, and is this enabled? Okay, so let's power it up and let's have a look to see what we've got on here. We'll have a look then. So I'm on voltage range, the thing's switched on. So the 2 things I'm interested in first, 3 things. Have I got 12 volts getting to the top end of the MOSFETs? Yes. Have I got power VCC to this chip, which is actually on this capacitor here? Yes. Is it enabled? That's on this component here. No. Okay, so this isn't enabled. That's why that's not generating any output. So now we need to have a look at this to see on the board view where the enable signal comes from. Okay, once more again to the board view. Let's have a look to see if we can figure that out. So, where's it? Oh, there we go. Yeah, okay. So, board view. I'll find it in a minute, guys. Yeah, here we go. Board viewer. Okay. Right, so this is our chip then, yeah. I'm just trying to keep it away from the inset. This is our chip. So this is the enable pin. In fact, the signal name is EN10, yeah. This is that white component, which is telling you it's a multi-layer ceramic capacitor, 47 puff. It's telling you what the component is. It's a capacitor, so it doesn't come from there, it comes from here. This is a MOSFET, yeah, and MOSFET. Let me just move the thing so you can see it. One moment. Sorry about that, guys. I just want to make sure you can actually see the thing itself. Yeah, okay. Right, so this is the MOSFET. This is where that signal enable actually comes from. I'm hovering the mouse over saying PM enable 10, yeah. So this pin will be ground, yeah, and this will be the gate. So this is the input to this MOSFET, yeah. Where does that go to? That comes from over here. Yeah, we can see it in yellow. And it looks like another MOSFET, so it's coming from this point. That's the output from this MOSFET. So again, this will be ground. This is the input, yeah? And the input goes to these various resistor, capacitor, resistor, saying like PSR, PSC, yeah? So, somewhere through one of these is that signal coming. Where does this one go to? Right, this one goes to the actual V coil, yeah? You see these are the coils, yeah? That's going there. This is a capacitor, so it's not coming through. Sorry, this is a capacitor. This is going to 3.3 volts. So I'm guessing 3.3 volts needs to be there. Yeah, probably this needs to be there. And where's the other one coming from? Here. And that goes to this controller, yeah? This is the output of here, yeah? And this is the other controller. And I'm guessing this pin is power good coming out of that one, yeah? Power good there. So, okay, so we need to have a look around now at these resistors and see what signals we've got. So, again, once more, back to the board. So, we know then that basically where the power, the enable comes from this. This actually comes from this chip over here. And we've got a number of resistors, capacitors that effectively have to have supply voltages present, various ones, to turn on the MOSFET that enables this, yeah. So really it's a matter of looking around this chip and seeing where the power God, no, I don't believe it. Oh, stop. So there you have it, yeah. We're back at the end of the video now. So yeah, after that last bit on board view, and I then went back to the GPU to investigate why there was no power good coming from the previous voltage stage. Yeah, I then of course discovered this. Where was this? I mean, whoever puts a 6-way PCIe there? Yeah, you stick them here. You stick them here, do you bloody hear me? You put them here, yeah, then you went here. You won't have these problems, yeah. Anyway, there you go, guys. I hope it was A, educational, B, entertaining, and C, you can have a good laugh at my expense. Okay, see you all soon on another one. Ciao for now, guys, and Merry Christmas to all of you.